So this one just more a trick. So I'm gonna go ahead and do it here. So they say there is a velocity functions and there is a particle, this initial conditions. So S of 0 is equal to -2. And then they say when the particle is moving left, you can write as much as V of t is less than 0. That already gonna give you some type of points. I don't know because less than 0 is going left. And then what you're gonna do is to find the 0 at velocity. So you're gonna say cosine of pi over 6 t is equal to 0. When is cosine pi over 6 equal to 0? When is cosine equal to 0? Pi over 2, good. So is equal to pi over 6t, or 3 pi over 2 is equal to pi over 6t. So if that's the case, I move divided by pi on both sides. So it's going to be t is equal to 3. Divided by pi on both sides times 2 on both sides. Or times 6 on both sides, sorry. So it's t equal to 3. And then t equal to, if I get rid of pi, I multiply 6 on both sides. So it's 18 over 2. So it's 9. So therefore, it's going to be between 3 to 9, 12, 0. How do I know they are left? Well, I'm plugging 1. If I plug in 1, I'm going to get positive because if I plug in cosine of pi over 6, it's positive. If I plug in, let's say it's 5, cosine of 5 pi over 6 is negative. And that just says cosine of 10 pi over 6 is positive. Traveling left is between 3 to 9. Is that hard?
Did you do the number line stuff with cosine pi over 16?
Mm-hmm. Pi over 60, yeah. Right, but do not evaluate integral at total distance. That's super easy. Just integration 0 to 6, absolute value v of t dt. They don't even want you to evaluate, which is that's kind of weak. You have to take account for both, but I will tell you one question that is not on the last test, which is all the way in the corner. That one is on the test, which is d to the dx of well, it's some type of question like this, not exactly the same one. D to the dx of integral of 1 over 1 minus t squared. You had to assume that because you don't know how to take integral 1 over 1 minus t squared, and you had to assume that is a function, and you integrate derivative, there's a chain rule involved, and the answer is on the bottom. Is you're going to get negative secant x? Yes, Sarah John? For B, good question. I asked you to write down yesterday. If you didn't, you got to write down today. Is when they talk about total distance between t equal to 3 and t equal to 9, it doesn't matter where you start. Imagine you run a track or field, right? And you're running 100 meters. I just want to see how much distance between 3 to 9. When t equal to 3 and t equal to 9, I just want to see how much the total distance travel. That doesn't need an initial condition. Now, if you are starting 10 feet behind, 10 meter, let's say Nikki is racing, he start 10 meter behind it. Although in swimming pool, that doesn't make sense. It would be concrete. But that just say other people start a little bit, they jump a little bit further or whatever. So their initial condition is different. Total distance doesn't matter. It doesn't matter of the total distance and total displacement. The only thing it matter is the final positions and final. Does that make sense? Because I just want to know what happened t equal to 9. Then, well, where do you start? Do you start 10 meter after or 10 meter before? Right? That matter. That's initial condition matter. So sometimes it matter in those cases. So total distance does not matter. And total displacement won't matter either. Find the acceleration from particle t equals speed is increasing. Well, that means I want to find out v of a, v of 4 is, and a of 4 is. I need to figure out v of 4 is going to be, v of 4 is what? Equal to 2 pi over 3, which is negative half, which is less than 0. So a of 4, that means I have to take a derivative. So a of t is equal to negative sine of pi over 6 t times pi over 6. I'm going to have to plug in 4 here. That's going to give me positive times negative is negative square root 3 over 2 times pi over 6. So they both negative, so therefore speeding up. Katie, did I make a mistake?
No, for the AFT equation, how do you get that as the, oh, no, right, never mind.
Chain
I
rule.
can't read. I was thinking with the integrals or the.
No, I'm trying to take a derivative. And that's it. Find the position of the particle at t equal to 4. That means I have to do what? Integral. Positions, right? Well, this one including initial condition as well. So it'll be cosine of pi over 6t. Now remember, you had to do a, this one's a velocity. So if you, in order to do this, you have to use substitution. This is not allowed to use substitution. du equal to pi over 6 dt. So 6 over pi du equal to dt. So it'd be cosine of u, and this is du, and 6 over pi. Any questions here? No? What's integration cosine u? Sine, right? So sine of pi over 6t times 6 over pi plus c. That's position. This is a harder point to earn. If you do this integral right, you're on a good track. Now you just have to apply the initial condition, which is you're going to plug this as negative 2 is equal to 0, which is equal to 0. C is equal to negative 2. And then S of t is equal to 6 over pi times sine of pi over 6t plus, actually minus 2. So far, any questions? That's the particular solutions. Now I have to plug in 4. So 6 over pi plus sine of 4 pi over 6, which is 2 pi over 3, minus 2. And this is not plus, this is times. Idiot. 6 pi sine 2 pi over 3. Did I make a mistake here? Hold on a second. I feel like I make mistake over there. C is 4. 2 pi over 3 is square root 3 over 2. Okay. So this one is square root 3 over 2. Minus 2. So that's equal to 3 square root 3 over pi minus 2. Minus 2 pi over pi. So is equal to pi 3 square root 3 minus 2 pi. I think that's my answer. Unless you can check if I did anything wrong. It's possible I did something wrong. This looks kind of weird. But the idea should be like this.
Let's see.
Mm.
You changed from negative 2 to negative 2 pi over 5.
That's just I have a common denominator. So I multiply pi over pi on the top and bottom. And this is a non-calculated section. Any question about this one? You should know how to take integration of U substitution like this. They are not hard. You have to get practice of trig substitutions. Let me know any questions before I move on. Do I want to cover the last one? Or you got the last one?